so now we're going to be getting into a step beyond what we did with the H positive and the OH negative. And we were able to figure out pH from either one of those. Now we're going to go in the reverse direction. We're going to start with pH, and we're going to find hydrogen and hydroxide concentration from that. So the mathematics fun continues. Yay us! Okay, so let's suppose that I have I want to find the log of 425. Okay, so you go to your calculator and you find the log of 425, and say we'll call that x. And let's say that when you solve that, x is 2.63. So the question is, what does that mean? Well, the word logarithm, like I said before, means exponent of a base. What is the base? Well, in this particular case, when no base is given, we call this a common logarithm, which means the base is 10, the most common number we use in our numbering systems. So that means then that this x is the exponent of 10, so 10 to the x equals this value right here, 425. Okay, now if you substitute 2.63 for the x, and you do this, I think you get actually 426. It's because of the rounding off that we do there. We're going to 3 sig figs, sometimes throws it off just a fraction. Not a big deal, but this is what all this means. Okay, so if I say then that the pH of a substance is 4.26. So the question here is, what does that mean? Well, like I said in the last lesson, the P of pH is an actual mathematical process called the negative log. And the concentration of hydrogen is the H here, so H positive equals 4.26. Now, using the same idea of what I just did up above there with 426 instead of 4.26, and now I have a negative log instead of just log, but the idea is the same. Negative exponent of 10 for hydrogen ion gives us 4.26. So the base is 10, the exponent is 4.26, but it's the negative exponent, so I've got to put a negative sign there, and that's going to equal to the concentration of hydrogen. So you get your calculators out, you punch in 10 carat negative 4.26, and you get 5.62 times 10 to the negative 5th moles per liter. Okay? Now, we can also figure out the concentration of the hydrogen from that, and there's two ways that we can do that. So let's take a look at the two ways of finding concentration of hydrogen from the concentration of hydroxide from the concentration of hydrogen. So number one, and I don't really care which way you do it. You know, you do whichever you want to do. I don't really care. As long as you get the right answer, that's what it's all about. And showing the process form, not just getting an answer, but showing the process. Process number one. We go back to concentration of hydrogen times the concentration of hydroxide equals 1 times 10 to the negative 14. This is Arrhenius' equation that he came up with for the K value of that equilibrium expression when water breaks apart in small quantities. All right? Now, we just found out that the hydrogen ion concentration is 5.62 times 10 to the negative fifth. And so we want to find out what is the concentration of hydroxide. We just bring that down and bring down the 1 times 10 to the negative 14. And you see you have a very simple algebra problem. Solve this, divide both sides by 5.62 times 10 to the fifth. And the concentration of hydroxide turns out to be 1.78 times 10 to the negative 10. And that will be in moles per liter. We are using concentrations in terms of molarity for this. So that's process number 1. Process number 2. In order to understand process number 2, we're going to go back to that equation, the concentration of hydrogen times the concentration of hydroxide equals 1 times 10 to the negative 14. Now, I'm going to take you down the trip of memory lane for Algebra 2 and or any other math that might have involved this. And that is by taking the negative log of both sides. So the negative log of the product of hydrogen and hydroxide ions concentration equals the negative log of 1 times 10 to the negative 14. Okay? Now, on the right-hand side, if you punch that out in your calculator, you get positive 14 or just plain 14. The theory of logarithms and exponents comes from something that you have dealt with, particularly with exponential arithmetic or exponential algebra. And that is, when you have the exponent of two bases multiplying together with different or even possibly the same exponent, you add the exponents together. So this becomes the negative exponent of hydrogen ion plus the negative exponent of hydroxide ion, and that sum will always be 14. Well, we also know that negative log is a mathematical process, which is why I use this. And so we're going to call this, as we've done before, pH. But here's a new one right here. This is called POH. And pH plus POH is 14. All right? So, using that idea, we said that the pH let me get that. pH was 4.25. Okay. So we said this is 4.25 for the pH plus the POH equals 14. So all we have to do is subtract 4.25, and the POH is 9.75. Now, we can do the same thing we do with the OH that we did with the H when you're given the value of that, and that is by understanding that this is the negative logarithm or negative exponent of the OH concentration is 9.75. So that means the concentration of the hydroxide is equal to 10, the base, to the negative 9.75. It's a negative log, negative exponent. And you type that out in your calculator, and you get 1.78 times 10 to the negative 10 moles per liter. Again, because it's a concentration, you can put the capital M in it. So if you take a look at what we did over here, you get the same answer. Now, you're not going to be doing this process where you're coming up with a formula from that. I just did that for you. But this is your choice as to which one you want to use. So let's take a look at another example. Let's say that the pH of the solution is 7.77, and you want to know what is the hydrogen ion concentration and what is the hydroxide concentration. Okay, so pH means the negative log of hydrogen is 7.77. So that means 10 to the negative 7.77 power equals the concentration of hydrogen. You hit 10 caret negative 7.77 to see what the calculator gives you. And I get 5.88 times 10 to the negative 7. I'm sorry, negative 8. My bad, I copied it down wrong. Times 10 to the negative 8 moles per liter. There's your pH, or that's your hydrogen ion concentration. Now again, there's two ways to figure out the hydroxide. I'll do both. Again, you use whichever one you want. Number one, concentration of hydroxide is equal to 1 times 10 to the negative 14 divided by 5.88 times 10 to the negative 8. And we get 1 point, oops. Yeah, we got 5, oh, sorry, that's wrong up there. That's supposed to be 1.70. Right there. My bad. If you're doing the calculator, where's he getting that number from? Oh, he was getting it from the next answer that I did, which is the 5.88 times 10 to the negative 7 moles per liter. That's process number one. Process number two, the POH is 14 minus the pH, 7.77, which is 6.23. And then the, since the negative log of hydroxide then is equal to 6.23, that's what POH means. That means 10 to the negative 6.23 will give you, now you have 5.89 times 10 to the negative 7 moles per liter. Either answer is acceptable. Again, a matter of rounding off created this slight difference in the two answers. Okay? So, your practice problems for this are the 5 problems on that front sheet. I'll give you 10 or 5 pHs. Now I want you to notice a couple things, and it's really important. Because a lot of you are making assumptions based upon what you've seen or heard or was even possibly taught. That the pH scale is only from 0 to 14. That is not true. The pH scale is right around -2 to right around 16. So when I give you negative pH, that's not a mistake, that is for real. When I give you a pH of 14.70, which is more than 14, that is not a mistake, it is for real. So, do these problems, have fun.